So actually, this is exactly the thing that we were talking about last notes, and we're going to revisit it with this idea of the union and the intersection. So we're talking about creating codes for cell phones, right? The little like code that unlocks. Distributions very similar to the table below. So this is a relative frequency probability, which means that they've done tests, and these are the numbers of which it appears. So this is not an equally likely probability. Excuse me. Let B be the event where the first digit is more than 5. Let C be the event where the digit is an odd number. And as we talked about above, 7 and 9 satisfy both of those. So there is an overlap between those two sets. Represent the sample set of these two events in an Venn diagram and find the union and the intersection of these two events. So representing it as a Venn diagram, we need to have a circle that represents B. We need to have a circle that represents C. And then we need to put a rectangle around it and label it something like U, which is the entire possibility, all of the other probabilities that could go into this. Every single probability that's listed out here as a number needs to eventually add to 1, which means that all of these probabilities need to be categorized somewhere in here. So we can start with just 0 and say, okay, well, where would 0 go in this Venn diagram? Does it satisfy event B, where the first digit is more than 5? These are talking about first digits. 0 is not more than 5, and it is not an odd number. So 0 is a probability that doesn't exist in either of those. So it goes outside of the bubbles. It goes in the catch-all of the rectangle around it, saying, hey, this is everything that's not B and C. Versus 1 is an odd number, so it satisfies C, event C, which is first digit is an odd number. So the probability of 1 can go into C. It cannot go in the middle because it's not more than 5. So this would be 0.300. 2 is not more than 5 and is not an odd number, so then that probability also goes outside in that rectangle area. 3 is an odd number but is not more than 5, so it goes here, 0.122. 4 is not more than 5 and it is not an odd number, so it goes outside. 5 is an odd number but is not more than 5. It is 5, so it does not satisfy B, but it does satisfy C, so that 0.078 can go there. 6 is more than 5, but is not odd, which means it satisfies B, but not C. So we can put 0.067 here. 7 is more than 5, and it's an odd number, so it satisfies both B and C. So it goes on this intersection piece here. That probability is 0.058, in other words, 5.8%. 8 satisfies B, but not C. 9 satisfies both. So this is a Venn diagram where you put down the probabilities of each of these situations happening. 0.058 is counted in B as well as C, so it's in two different places at once, and same with 0.045. If you add all of these up, it should add to 1. Also realize you have 10 numbers here, and if I go through and count, I've got 10 numbers represented here. So I've represented all of the numbers in my Venn diagram situation. Okay, and now we want to find the union of B and C. Remember, it's the bold. It's this idea of putting all of the probabilities in there together, and that is what they are. And so it's this addition, 0.067 plus 0.051 plus 0.058 plus 0.045 plus 0.300 plus 0.122 plus 0.078. I would like for you to add those all together and tell me what you get. You should get 0.721. If you notice on your notes from last time that you already had the probability of B and you already had the probability of C. So you could have added those two probabilities together, but just realize you would have had to have subtracted out 0.58 and 0.45 because it's counted in the probability of B And it's also counted in the probability of C. So if you add that in twice, you'd have to take one of them out. So you would have had to subtract out 0.058 and 0.045. Okay, the intersection of B and C is only what they share. And so in this instance, we wouldn't do the multiplication because we have a Venn diagram. We understand that the intersection between these two is everything that they share. It's this and this, so it's 0.058 plus 0.045. Adding those together, you should get 0.103. Okay, our first venture into making a Venn diagram. I know it's something that you might be a little bit nervous about or worried about or have negative feelings about from previous classes. I think Venn diagrams are really interesting. I think they're very much puzzly. I think they're one of the more puzzly things that we do in a math class. And so we'll just keep practicing it until you feel comfortable and just keep asking questions and work on it. Okay. Example 2, the blood types of people can be one of the 4 types, O, A, B, or AB. The distribution of people with these types differ from one group to another. Here are the distributions of blood types for randomly chosen people in the USA, China, and Russia. So these are probabilities that they have gone out and found, and we're making predictions based off of these probabilities. It first asks, what is the probability of AB in the USA? And notice that it is left out. What do you think is going to be the strategy here in terms of solving for AB? Notice it's the only one that's left out for the USA, which means that this probability, this probability, this probability, and the left out probability have to add to 1 in order to total up to 100%. So 0.43 plus 0.41 plus 0.12 plus question mark is going to give us 1. Subtracting out all of those probabilities from 1, we should get 0.04. Carlton lives in the US and has type B blood. Type B blood can only receive O from O and B. What is the probability that a randomly chosen USA citizen can donate blood to Carlton? So he can only receive blood from O or from B. He's not required to get it from both O and B, right? It's not some like mixture where they have to bring in both O and B and mix it together in order to like put it into your system. Not how science works. It's either O or B will satisfy the conditions of Carlton getting blood donated to him. So it's either this or that. The probabilities get larger when you start to add more options. And the way we make probabilities larger is by adding them. So we add those 2 probabilities together, and then that will give us the total probability of Carlton being able to accept blood from a randomly chosen citizen in the United States. Adding those up is 0.43 plus 0.12, so that should be 0.55. What is the probability of randomly choosing a person from the USA and a person from China with type O blood? And here is where you need to be careful of and. We chose somebody from the US and we chose somebody from China. What are the probabilities that both of them have type O blood? It's not like, hey, we picked somebody. What's the probability of them being from US or from China with type O blood? It's, hey, we picked one person from US and one person from China. What's the probability that they both have O blood? So the probability of O from the USA and O from China is the bridge of those 2, which means that we need to multiply those probabilities. O sub C is China, O sub U is the States. The probability of O in the United States is 0.43. The probability of O in China is 0.36. Multiplying them together, we get 0.1548. Notice that that number got smaller, right? We multiplied these numbers that were less than 1. We got a number that resulted in a smaller number than either of our original ones, because that's what happens when you multiply with something that's less than 1. And it's a small probability. It should be a small probability. You're pulling from two completely different countries that have massive populations and different probabilities. And O is not one of the highest probabilities out. Well, actually, it might be the highest probability out there. But it's still not a terribly high probability, which means that it gets less and less when you start to focus on it too much. Okay, what is the probability of randomly choosing 3 people, 1 from the US, 1 from China, and 1 from Russia with type O blood? You should have multiplied these all together in order to find your final result. We already knew what probability of O from the US times probability of O from China was. That's 0.1548. Then we just need to multiply O from Russia, which is 0.39. Multiplying it out, we get 0.060372. It got even smaller, even though 0.39 is a pretty big probability compared to the rest of the table. It's now adding in this extra thing where we had to get O from every single country, which is pretty nitpicky. It's pretty small probability. And it shows that 6% is the probability there, which is pretty small. It gets smaller and smaller.